All right, how's it going, everybody? Today we're going to be covering notes 9.6, solving logarithmic and exponential equations. Now, we're basically going to bring in everything that we've talked about in this unit, and we're going to bring it all together, the circle method, of course, using the calculator to find some values. But there's some special properties that come with logarithms and exponentials. And so here we go. So it says properties of equality for exponential equations. So one of the properties that we have to know, it says if b is a positive real number other than 1, remember your base can't be a 1, if not, nothing really happens because 1 to any power is the same, then, so here's the rule. Notice, if I say that the b's are equal, well, that makes sense, right? It could be like a 2 with a 2, a 3 with a 3, but as soon as I give this one a power, and then I give this one a power as well, just with a different variable, of course, the idea is if I want that equality to exist and the bases are equal, well, then by force, the powers should be equal to each other, right? The only way to maintain that equality is if the two powers are equal. Now, this rule only works if the bases are exactly the same. So that's why if you look at example number 1 here, we look at it and we say, okay, it's an exponential with a base of 2. This is an exponential with a base of 2. So that means the rule can now apply, meaning this power and this one, if equality needs to exist, well, then that power, x minus 4, has to equal 3x minus 14. It's the only way this works, right? That's the only way to maintain that equality. And now all this has become is a simple algebra 1 question. We're going to move our x here. So we have 2x minus 14. Again, we're doing our opposite operations here. Let's add the 14 to both sides. So now we're down to 10 is equal to 2x. And finally, of course, we divide by 2. And just like that, we have our answer that x is a value of 5. And we can, of course, always double check that with a calculator to see if the two sides will match. But in an exponential function, any x is fine. Remember, the domain of an exponential function can be any number we want. Now, when you look at number 3, now number 3 gets a little more interesting. See, here's the issue. I see a 6, but then I have a 36. That doesn't match. So that means I cannot make my powers equal to each other. Only if they match, we can make them equal. So here's the thing. Yes, this is a 6, and yeah, we have a 5x minus 4. Can't do much there. But if you think about it, that 36 can be rewritten. I know that 6 goes into 36 if I give it a power of 2. See, there's the matching base. This will give me the 36. And if you're wondering, yeah, but what about this power? Well, it still belongs to it. So we write it up there as well. And now that they match up, look, we can even distribute this already. So then it just says 6, 5x minus 4, 6 to the power of 6x minus 2. The bases match. And if the bases match, well, the rule is these powers have to be equal to each other. So let's make them equal to each other. 5x minus 4 is equal to 6x minus 2. Let's get our x's together, of course. So we're going to move our 5x to the other side. So negative 4 is equal to x minus 2, which brings us to our last step of adding a 2 to both sides. And so x, don't want to mess with that, x is officially negative 2. And there's our answer. And again, exponential functions have no domain issue. So that's why any answer we get will work for these problems. And then we have this one right here. Now, this one gets a little more interesting. This is a 100. This is a 1 over 10. We need the bases to match. So yes, we're going to do a little manipulation here for some of these problems. So when we manipulate this problem, I'm going to manipulate this one first. See, if I have a 10 at the bottom, all I have to do is give it a negative power. And because it's just a power of 1, well, then I'll give it a power of 1. And of course, we still have that power up here of x minus 3. Now, I did this one because it was easier. I saw a 10. Now, this one, it's a 100, but we know that we can change the 100 into a base of 10. We just have to make sure that we give it a power of 2. But of course, 10 squared is 100. The bases match. You just can't forget to bring in that power of x. And I don't really need a parentheses this time because they're right next to each other. So check this out. 10 to the 2x is equal to 10, little distribution there, negative x plus 3. The bases match, which means by force, the powers should be equal to each other. That's our rule for the day here. And so once we start to solve this, well, let's start moving things around, right? I'm going to add my x together. Whoop, x, there you go. To both sides. So now I'm at 3x is equal to negative 3. And of course, my last step is to divide by 3. And when we do that, we get our answer that x is equal to negative 1. And again, because it's an exponential function, domain is all real numbers. Any answer we get counts as our solution for this problem. All right, so give it a try. Try number 5 here. So we can pause the video for a moment so that you can give number 5 a try, see if you understood the concept. All right, now that you've had an opportunity to work on it, hopefully, here's how you can check your answer. If you got an answer of 1, then you did this problem correctly. If you didn't, then talk to your neighbor, talk to someone around you in class who did get the answer and see maybe they can help you catch the mistake there that you may have made. Now, we're going to continue here on the other side where we're going to talk about the change of base formula. Now, you have to remember one thing. When you're working with a calculator, even with Desmos, the Desmos Scientific, we know that there's some limits to it, right? When I bring in my Desmos calculator, I press function. This is the scientific, and all we see is log and natural log. So we can't do any base we want. Well, actually, we can. And that's what this is right here. This change of base formula is going to allow me to use any base I want. And the only 2 bases my calculator can do are base 10 and base e, right? Log of e or natural log. So here's how you can now do any log that you could never do before. Now we're going to show you how you can do them. So it says log base c of a. Well, remember, log base 10 is something I can work with. This is a fraction here, log base 10. This is my base, so we're going to put that at the bottom. This one is the log value, so that one goes on top. And we're doing a base 10 so that my calculator can handle it. Same thing on these. When you're working with logs, right, of c, either any number, if you don't want to use this button on the calculator, remember we also have natural log available for us. And just the same, the base goes at the bottom, remember, base, bottom, and of course, our log value goes on top. So remember, let's check it out here. Remember, we would never be able to just type this into a calculator. But what we can do is I can change it using the change of base formula. The change of base formula says I'll turn it into a fraction. And let's see, I'm going to go with logs on this one. And I'm going to do log base 3. The base is the bottom. Notice how it's not a base anymore. And log base 8. And remember, we could never do this question before on a calculator. We're about to do it right now. So we're going to turn it into a fraction here. And now we're going to bring in the function. We said log of 8 over the log of, I believe it was 3. And you see the calculator was able to do a log for us that we were never able to do before. My answer is 1.893. So 1.893 is my answer. And again, look, we just did a log that we were never able to do before. Now, I do want to show you something here, because remember, my other option was to do a natural log. Well, look at what happens if I had done the natural log instead. So I'm going to keep that answer there so that you can see it. But if I had done a natural log instead, here we go. So I'll press the natural log, and I'll press the natural log at the bottom, just to get it ready. And remember, there was an 8 on the top and a 3 at the bottom. And what do you notice about the solutions? They're exactly the same. So that's why it doesn't matter which one you use. Just make sure that you use the log base 10 for both or the natural log for both, but don't mix them together. So now you can do any log from your past that we couldn't do before with a calculator. Now you can using the change of base formula. And so look, here we go again. This is not a base that my calculator can handle, but I can go natural log of 24 over the natural log of 6. And you see, this is what I was telling you earlier. It doesn't matter which one you use. You're going to get the same results. So let's see what that is. All right, we have it here anyways. So let's type it in. Oh, there it is. All right, so it was a natural log of 6 at the bottom. And at the top, we had a natural log of 24. All right, just like that, there's our answer, 1.774. So 1.774. Again, we just did a log that never before could have been done on a calculator, but now we can. But you have to learn the change of base formula. And you can either go with logs or you can go with natural logs because you're going to get the same answer no matter what, as you saw earlier. So now, because we have just learned that, we can actually find answers to questions like this. Now notice this is an exponential function. Round your answer to the nearest thousand. My x is stuck in the power. So if my x is stuck in a power, then I'm going to bring in a log. A log, here comes the circle method, will allow me to bring that power down. So this is log base 2 of 7, which is equal to x. And if you notice, the x is already by itself. Now, this is not something that I can do on a regular calculator, so I'm going to rewrite it. I'm going to go log of 7 over log of 2. Remember, this is a base 10. And then when I get the calculator going, we're going to notice that the answer for this is 2.807. Now, I just showed you how to use a calculator. So I just wanted to give you the answer there so we can get through the notes and you could get to the work. But you see, that's why the circle method helps. And now we know how to do any log on a calculator. So let's see. Let's try one more together. And then you could do the you try at the bottom. Now, this one a little bit more complicated. It says 7 to the power of 9x is equal to 15. And yes, the x is stuck in a power. Well, then there's only one thing I can bring in. We're going log. Logs will allow that power to come down. So here we go. Log base 7 of 15 is equal to 9x. Now, this one does require a little bit extra work, of course. Notice how we have a 9 here. So normally we would say, okay, well, let me divide this by 9. But this is not something that my calculator can handle, right? This is log base 7 of 15 over 9. Well, we wouldn't be able to type it in like this. So we're going to think about it. I'm going to take a moment here and just work on this part right here. We'll do it off to the side a little bit. This can be rewritten as the log of 15 over the log of 7. And then I'm going to let the calculator kind of give me some answers here. And when I do type this in, I end up with 1.392. So there's the answer to the top part right here. This pink circle, this is the answer to it. So I can now come in to this problem and use, instead of log base 7 of 15, I'll go 1.392 and then divide it by 9. And that's what's going to give me my approximation that they said to the nearest thousand. So when I divide these values right here, we end up with, well, let's type it in. Let's see. So 1.392. Whoa, let's clear everything actually. All right, so what are we going with? 1.392 divided by, wrong thing there, divided by the 9. And there's our answer, 0.157. So 0.157. All right. All right, so there you go. This is our solution for this problem. Again, it was an exponential. We have no worries with these answers. All right, so give this one a try. Give number 9 a try. Let's give you a moment. We'll pause the video there so you can try out number 9. Okay, and now that you've given it a try, let's check your answer there. Notice it's got a little interesting there. I approached it in a slightly different way for this one. If you notice, I did this first, got my decimal, then we divided it by that 4 to get rid of it. Okay? All right, so let's go to the other side, last side here for the notes. If you notice, it's the last page of the packet. That just means one thing, right? We're getting close to the end here. We will be getting ready for our next test coming up next week. Okay, so now we're going to talk about logarithms, properties of equality for logarithmic equations. So it says, if b, x, and y are positive real numbers, except for the b, don't forget the b can't be a value of 1, doesn't work for that, then blank if and only if blank. All right, here's the rule. It's a property of equality. So here's a log base b, here's a log base b. The equality is the big thing. If we want these two to be equal to each other, then that means the x and the y, right? If we want equality to exist and to have the same base, then the x and the y have to be the exact same value. So when this happens, you have a log on both sides with a base b, then go for it. X, make it equal to the y. Whatever's in here, make it equal to this. Now, we have a little bit of an issue though. Remember, when it comes to logarithms, they have a vertical asymptote. And when you have a vertical asymptote, so let's bring in the parent function really quickly here. So the parent function goes through 1. It goes through the base and 1. So 1, 0, base 1. So there's the parent function of a log. But you have to remember, there's an asymptote here. See, your graph is not allowed to go behind the y-axis, right? We're not allowed to do logs of negative numbers. And so that's why it says when working with logarithmic equations, you may have extraneous solutions, because what if you get a negative value? We are not allowed to take logs of negative values. We can only take logs of positive values. So it says the domain of a logarithmic function is positive numbers only. Remember, 0 doesn't even work either. Look at that. The asymptote is right at 0. So it's positive numbers only. So any quantity that results in taking the log of a negative, so if you end up plugging in a number, which is what we're getting at, if you plug in a number and you end up taking a log of a negative value, that's what we call an extraneous solution. Because remember, look at this picture. Logs never work with negatives. We don't work with any negative values, only positive. So here's the catch, right? When you work on an exponential, whatever answer you get is fine. But when you work with a log, you're going to have to check your answers. And that's basically what they're letting us know here. So check for extraneous solutions. And you're going to see that question pop up on the test, on the homework, because you might have answers that just don't work. All right, so check it out. Now, when I look at number 12, yes, it's a log, so I will have to check my answer at the end. But this one is a base E, this one is a base C, so they match. And if they match, remember what that means for us. When they match, all we have to do is make this equal to this. I don't even worry about the log. Keep that in mind. We don't even worry about it. I just make them equal to each other because they have a same log with the same base. So it equals x plus 5. All right, let's start solving. Let's get rid of the x. 3x minus 7 is equal to 5. Add the 7, of course, to the other side. 3x is equal to 12. And finally, divide by 3. So x is equal to 4. Now, I can't put a little square saying, yes, this is my answer yet, because I need to double check. So here comes our quick check. All right. So I'm going to check it on this one first. It says the natural log of 4 times 4 minus 7. Well, that's 16 minus 7. And 16 minus 7, and here's what I need you to notice, is a positive, right? A positive 9. So, yeah, that checks out. I don't even have to finish it. This is what I care about. I'm just making sure that I end up taking a log of a positive number. That's why I check this one off. And then when I look at the other one over here, it says the natural log of x, 4 plus 5, which is the natural log of positive 9. And that's why this one checks out, because of that positive. So yes, this is not an extraneous solution. It is an answer to this problem. Okay? And then you might get some easier ones. I mean, some of these can be a little bit easier. The idea is this, though. Remember, they both say log base 4, log base 4. Perfect. That just means one thing. I'm going to make the log values equal to each other. So here we go. 7x minus 4 is equal to 10. Add the 4 to the other side. So some of these are shorter than the others. 7x is equal to 14. Divide by 7, and x is equal to 2. Whoa, I put a box around it, but I should be checking first. I could slash it after just in case. All right, here comes my quick check. Now notice, I really don't have to check it here because there's nothing for me to plug into. But I can check the other one. Log base 4 of 7 times 2. There it is. I'm plugging it in. Minus 4. So I end up with log base 4 of positive 10. And that right there is what gives me that check. So yes, this is an answer. No extraneous solution. We're good to go. All right. Well, let's try it again. So notice they have to have a matching base. But then you get to number 14. Look at this one right here. When you look at number 14, we only have one log. So then the question is, well, then how am I supposed to approach this if all I have is one log? Keep in mind, this is never going away for us. Go exponential with it. Remember, you have a log. The x is stuck in there. Go exponential, and that log goes away. Look, 2 to the third is equal to 5x minus 17. 2 to the third is 8. You work that out right away. And now it's just become a very simple problem for us. Add the 17, of course. 25 is equal to 5x. Divide by 5. And we get x is equal to 5. Now, we only got one answer, and there's really only one place that I have to watch out for. So let's see. Let's do a quick check. Log base 2 of 5 times 5 minus 17. Yeah, that's definitely a positive value right there. I don't even know what number it is, but this is 25 minus 7. So look at that. This is good. This is what checks out. You don't have to finish it. As soon as you realize, oh, it is a positive, then it worked. All right, number 15 is very similar. Look at that. We're going circle method. So if you get two logs equal to each other, well, then make the values equal to each other like you did here. But if you only have one log, well, you know what to do now. 3 to the power of 4 is equal to 10x minus 9. 3 to the 4, well, let's see. 3 to the power of 4 is 81, is equal to 10x minus 9. Add the 9. Here we go. Nice basic algebra here for you. 90 is equal to 10x. Divide by 10, and just like that, we get an answer. That x is equal to 9. But I'm going to do a quick check. I'm only checking it in one place anyways. So it says the log base 3 of 10 times 9, which we know is 90. And all we're going to do is take away 9. This is definitely a positive right there. So it checks out. Okay. All right. Well, that brings us to the last one. I know there's no you try problems on here, but we do have this one here, number 16, last one. If you notice, we saved the best for last here for this unit. We only have one log. All right. Well, I'm going exponential with it. And yes, you have to go all the way around. That's fine. Look at this. 3 squared is equal to x squared plus 10x plus 25. Well, you should work this out, of course. Notice that's been our very first step every time. But when you look at this problem, we don't have a single x like we did in all the others. We have a quadratic. And if you think back to when we were working with quadratics, remember when you're solving a quadratic, there's only one thing they can equal for you to solve, and that is, of course, 0. Then I'm going to subtract my 9 because I need a 0 to show up on any side of this equals. So now it's x squared plus 10x plus 16. And of course, if it has a power to it, if it's a quadratic, then we can do the quadratic formula. We could do completing the square, or of course, we can just factor this thing. And I know for many of you, you've been using the X factor, the lattice method, the diamond method. People call it different things. Here's our 16. The 10 is at the bottom. Everything is positive, so we get positive and a positive. And yes, this is an 8 and a 2. So let's see. X positive 8, x plus 2. But remember, we're not done. We still have to make each one of these equal to 0. So x plus 8 equals 0. X plus 2 is equal to 0. And then we do some basic solving. X is equal to negative 8, and x is equal to negative 2. But remember, we do need to check these answers and make sure that we don't have any extraneous solutions. And yeah, look, we can plug it in here into this one. All right, so let's see. Log base 3. All right, I'm going to try the negative 8 first. Let's test that one. So negative 8 squared plus 10 times negative 8 plus 25. My only concern is that it's positive. I don't care about that 2. I just want to make sure that all of this in here ends up being a positive value. So yeah, when we're looking at this one, I just need to let you know, I'm going to let Desmos handle this for us. Just type it in. And I'm going to do the same thing for this one with the negative 2. The concern is we just have to make sure that when I put negative 2 squared plus 10 times negative 2 plus 25, right? My biggest concern, and this was log base 3, I almost forgot the 3 there. My biggest concern is that all of this right here and all of this one ends up being positive inside. Again, I don't even care what number we get. But of course, we're going to let Desmos handle it. And so taking the liberty of doing that already. So when I plugged in a negative 8, right, exactly with the equation they gave us, I got a positive 9. When I plugged in a negative 2, I also got a positive 9. So if you notice, I got a positive 9. I got a positive 9. Hey, this checks out. We said as long as I'm taking a log of a positive, then we're good to go. So that means this is an answer, and this one is also an answer. Now, be careful. In the homework, there's going to be some problems where they are going to give you extraneous solutions. So if you were to get a negative, let's say for this one, I would have crossed out the negative 8. So the other thing I want to mention is, look, it's okay to get negative answers because when you type them in, they might work out. So don't assume that just because the answer is negative, that it's not an answer to this problem. So with that said, everybody, get started on the homework for this assignment. Have a wonderful day, and I'll see you as soon as I can. Have a good day, everybody.